We're in our second nugget of understanding the building blocks. We're laying the foundation, all the Lego pieces that we need to build this structure of voice over IP and to get everybody in this series onto the same platform before we move into a full discussion of gateways and gatekeepers. In this nugget, I have in mind to look at the other two major building blocks, starting off with the big ones, the call control agents, the servers that run the whole voice over IP network, and then wrapping up by looking at the 4 call control models that Cisco has designed and given you as design guides for voice over IP networks, including wide area network connections, including single site deployments, all of the models that you can use when you're designing a voice over IP deployment. So let's get going. Well, let's start off with the most central piece of your voice network, the call control agents. These servers are at the core of everything. They control the phones, they control your features. That's going to be when you get a ringtone on your phone, you get dial tone, anytime you push a digit on your telephone keypad, all of that is being controlled by the call agent. Now you can see that there's 4 of them that I have listed on the screen. The good news is that it's really boiled down to 2 of them. Top one is Call Manager, second one is Call Manager Express. I'm going to start at the bottom ones, the Cisco SIP proxy server and enterprise gateway, because you can see they're end of life. The reason I'm talking about them is because you may encounter them in the real world. You may hear people talk about them because they've been out for a while. And the Gateway Gatekeeper certification exam is not always the most up-to-date. It's been updated fairly recently, but you may just encounter this as one of your options and go, oh, well, that's probably not going to be the answer. So the Cisco SIP proxy server was how Cisco added SIP support in the early days. Meaning, back in the day, Call Manager 3.x, and you could even go back further than that, 2.x, 4.x, none of them really had SIP support, which is quickly becoming the signaling protocol of choice as it's emerging and going through its various revisions and getting more features added to it. And all the other vendors were saying, oh, SIP is the way to go, SIP is the way to go, and Cisco was saying, we don't support it. So they went ahead and created this product known as the Cisco SIP proxy server. It ran on Sun Solaris. That was the operating system. It was all command line based. It was not pretty. But what it gave them was it was a system that they could give to service providers that they could run a SIP to a massive amount of customers. For instance, you could have a service provider, which is considered an ITSP, an Internet Telephony Service Provider, that maybe is going to provide outside PSTN calling for a client over voice over IP. Well, they could actually run, using the SIP proxy server, a SIP trunk to a customer, and that customer could then have their internal voice over IP network. Anytime somebody dialed 9 for an outside line, it would cross the trunk to this service provider managed by the Cisco SIP proxy server, and that would route out to some PSTN POP or central office and would leave the voice over IP network. SIP proxy server could also manage SIP devices, but it was primarily used in service providers, and not many of them at that. You would hear a lot of it, but you would never really hear of too many people implementing it unless you were in the service provider realm. The Cisco Enterprise Gateway, it ran on this runs on the same servers as a Cisco Call Manager, and what it was designed to do is be a gateway between a voice over IP network. It was really a server-based gateway to where you could have voice over IP over here, and you could have a traditional time division multiplexing network like a PBX system or PSTN link, PRI, ISDN line, one of those kind of things. And the enterprise gateway would be the device kind of intermediating between those two. It would be the one converting between those two networks. But nowadays, the reason this guy's dead is all of that functionality has been moved to routers, and our voice routers with voice modules can do the functions of the enterprise gateway. So good news for all of us is it's boiled down to 2 products which have more than enough learning for themselves. Cisco Unified Communication Manager, aka Call Manager, and Cisco, and I'll say it again, Cisco Unified Communication Manager Express, aka Call Manager Express. Let me first talk about the names because it's always changing. Call Manager is now considered the old name. This was what Cisco ran for years. It was the original product that they released was Cisco Call Manager, and the original version was 2.4. It's strange that they didn't start from 1.0 or something like that. But it was 2.4, and it was called Call Manager, and it became 3.0. It was called Call Manager. 4.0 was called Call Manager, and then at some point, Cisco released their new unified strategy. Meaning they used to go. Anyone remember this? Avid. Architecture for voice. Oh, wait. I spelled it wrong. It's that old. Avid. Architecture for voice, video, and integrated data. That was Cisco's original strategy and marketing scheme behind this, to get you voice, video, and integrated data all on one network. The problem is Avid never caught on. People were like, well, what's Avid? Is it some kind of product? Is it a router? Nobody knew. So Cisco was like, that's a bad name. Let's call it Unified Communications. That's nice and obvious. Voice, video, and data. It's all unified over one network. So when they did that, they renamed Call Manager to the Cisco Unified Communication Manager. But that's such a long and cumbersome name. Nobody wants to say, hey, what version of Cisco Unified Communication Manager are you running? They just say, what version of Call Manager are you running? I mean, Call Manager is such a more convenient name that even though they've done away with it, it's been about, what's the date now? We're almost into January 2009, and it's been about a year since they made this change, and everybody still calls it Call Manager. This is too much of a mouthful. Same thing, Call Manager Express has that same name. It's just everybody calls it Call Manager Express. So Call Manager has gone through many different versions. 2.4 was it's originally released on Windows NT. Was the operating system. Version 3.0 moved Call Manager to run on Windows 2000 Server as its foundation platform, and this is really the version where Call Manager got traction. This was where it went mainstream, businesses started to deploy it. 3.0, 3.1, 3.2, people were like, it's bleeding edge, it's crashing, it's still buggy. Around version 3.3, was where Call Manager became like, okay, it's stable, it's viable, and they started releasing, 3.3, release 4, Service Pack 90. It was just, tons of patches, tons of releases, and it became a stable product. Now, Call Manager finally moved from, and I will say, first off, before I go any further, 3.0 is still in a lot of places. And the reason why is because people are approaching Call Manager the same way they approach PBX systems. Once you get it, it's running. You just don't replace it for years and years to come. There's no need to upgrade and patch and all that kind of stuff. So 3.0 is in a lot of places, and a lot of governments as well. I've run into it in a lot of government agencies because governments have to go through a nightmare of litigation to get anything, at least the U.S. government. We go through nightmares of litigation to get these versions approved and all that kind of stuff. Cisco's coming out with new versions of Call Manager like every other day. They're like, oh, new version, new version. Government is like, let's just find a good stable one. So I've seen a lot of Call Manager 3.3, 3.4 releases in government organizations. But for the enterprise network, where most of you are, I will say version 4.x and 6.x are going to be the primary ones that people are going with. 4.x is still running on Windows Server 2000, and actually they released 4.3, which upgraded the foundation operating system to Windows 2003. As its foundation operating system. This currently, as of January 2009, is the popular one. People are like, this is sweet, we love it, this is the solid version. But 6.x is quickly gaining traction. Matter of fact, by the time you hear me saying this, 6.x may have overtaken 4.x because it's moving fast. 6.x moves Call Manager to an appliance model, meaning it's running on Linux. And you can't access the foundation operating system. In this one, it's not an appliance, meaning you can play with Windows, you can get in the event viewer, you can use it for troubleshooting, you can turn Windows into an FTP server, TFTP server, you can put Office, Microsoft Office on the thing, and it'll work just fine. The operating system's accessible. In 6.x, and I should now bring into the picture 5.x as well, Cisco went ahead and said, let's make the operating system unreachable to the end user. It's an appliance model, which makes Call Manager a lot more stable. I'll have to say I fought it. I fought 5.x, I fought 6.x, because I thought it can't be as good. I like the Windows versions, I know it. I became like I don't know, You know people that you meet and they're just like, I'm not upgrading. This works just fine. My Windows NT workstation is great and I like it. Or like my relatives. I still have my mother-in-law who's on Windows 95, and I'm like, come on, upgrade it. You need Windows XP, and she's like, it works, it's fine. I've become like one of those people, right? Because I'm like, 4.x, good, I know it, it's colorful, it's pretty. 5.x, 6.x, the interface looks totally different, but I can say after using it for some time now, it's so much better. I love I love 6.x. 5.x is what you'll probably see on the Gateway Gatekeeper exam. Enough of this digression of versions, right? 5.x is probably going to be the version on the Gateway Gatekeeper exam because at the last major revision, which was pretty recent, this was the version that they based it on. So 5.x was the was the new enterprise suite that ran on Linux. 5.x quickly moved into a 6.x model, which was, I would say, the first real solid mainstream for everybody. This was primarily meant for very, very large networks, enterprise organizations. 6.x was the one for everybody. Small business, medium business, large business. Everybody can run a version of 6.x, and it looks great. So Call Manager is very stable. 4.x, 6.x being the major platforms you're going to run into in the real world. 4.x being Windows, 6.x being Linux. Now the other call control agent is designed, this is for small business. Small business. Call Manager Express, or Unified Communication Manager Express, runs on a Cisco router. Call Manager Express is all command line driven. It does have a GUI, but it's not very pretty. Definitely not like the full Call Manager suite. It is designed for organizations that would be, now Cisco would say probably 200 phones or less. I would probably say maybe 100 phones or less. But once you start moving into 100, 150 phones, I'm usually like, let's go Call Manager all the way, because you're wanting those kind of features. Call Manager Express gives you a lot of features, very powerful platform. As a matter of fact, that's what the whole CCNA voice certification is about. If you've gotten into CCNA voice, you've learned Call Manager Express. Powerful platform, very flexible, gives an awesome solution for a small business, all in one kind of device. If you've got some time, if you haven't heard of it, you might also look at the UC500 series. Whew! What a killer platform. That is a firewall, a VPN concentrator. Well, I use concentrator loosely, but a VPN termination device. It is a Call Manager Express platform. It is a voicemail, all in a box that looks like the size of a Microsoft Xbox. I mean, it's insane. It's an amazing product. But those are our two primary call agents. The Call Manager large business and medium business, Call Manager Express for small business environments. I could have probably talked on about Call Manager and Call Manager Express for a good 90 minutes, and I'm sure I would have started some live demonstrations. But we will see more of at least Call Manager in this series. Call Manager Express we'll mention here and there, but really this series you'll see some configuration inside the Call Manager. But there are two dedicated series for those two products. There's CCNA Voice, which covers Call Manager Express, and there is CIPT, which covers the Cisco Call Manager. So if you want all the scoop on those configurations, you definitely want to check those out. So now let's look at the design models. How do you design a voice over IP network? What are the supported models by Cisco when you're setting this up? Well, the first one is a single site call processing model, and this is the easiest of them all. This means you've got one location. All your devices are in a single campus network, and campus doesn't have to mean large. It just means this is our single environment. This is our office of 100 people, 500 people, 10,000 people. It's all one location. All incoming and outgoing calls go to the PSTN, so you don't have to worry about wide area network links compressing your voice. Just like you can see down here, we use G.711. Audio codecs. They're very high quality. That will allow you to send audio at extremely high quality between all the devices because bandwidth isn't an issue. All our calls go in and go out of the PSTN, and there's a lot of considerations. We're going to talk about the gateway configuration for that. A lot of setup for that, but you don't have anywhere near the concerns or considerations of some of the other deployment models. This is the simplest model to deploy because everything is in one location. Best thing that you would want to know is to, number one, have Call Manager redundancy. Call Manager should be more than one server. The exception of that is CCM This is a fairly new product. It's been out for a little while. CCM Business Edition, I believe is what the name of it is. That is an all-in-one server solution, a single server solution that has voicemail and call processing on one box. Normally you got to get a Unity server to provide voicemail into the network, but Call Manager Business Edition is designed for smaller environments, 200, 300 user kind of environments, where you want a single server solution, but knowing that if that single server dies, everything goes with it. In full solutions, you want more than one for redundancy purposes. But everything is just, pretty much plug and play in this kind of environment to make your voice work. Okay, I did not mean to say plug and play as my final statement of that last slide. There's in the voice world, there's never really anything that's plug and play. There is a lot of configuration to the single site model. It's just out of the 4 that I'm going to talk about, this is the second, it is the easiest to deploy. The second is the central call processing model. And I love this model. It's just a cool model to set up and work with. In this environment, you have a central site. These are your devices here. These are your phones that have all your call manager clusters at one location. All of the remote sites have phones. Those are IP phones, but they get all of their call control from the centralized cluster, meaning they go across the WAN to get their dial tone when somebody's dialing a number on their phone. That's all going across the WAN, being processed by the centralized call manager cluster. Everything is centrally controlled and administered. That's one of the benefits of this model. It's almost as easy to set up as the single site deployment, the one you just saw, but because everything's centralized, you just have to now worry about some of the remote phones and some of the routing that needs to take place to make sure these remote phones are working. So each location, this is a key point, does need a PSTN and WAN connection. Now, in a mind of an entrepreneur or somebody who's very thrifty and wants to save money, you might be thinking, well, we just need a PSTN connection at the central site, right? And all the calls can go over the WAN and use that centralized PSTN connection, correct? And the answer to that is correct, except for one issue, and that is emergency calling. In the United States, when somebody dials 911, that's our emergency code. Dial 911, that's going to, the fire department, police department, all those kinds of things. They don't have a voice over IP locator system. They use your exit point into the PSTN as a location value for you. So if somebody at this remote site dials 911, that call goes over the WAN and leaves the central PSTN connection over here, you're going to have all the emergency personnel showing up at this site, whereas this building burns to the ground. So you need a PSTN connection, at least one line at the remote sites for emergency calling. You can definitely trim down and do some over the WAN call routing for all your other calls, the normal calls, and you can even do some toll bypass magic. We'll talk about that later on. It's called THO, tail end hop off, where you get to go across the WAN and hop off at the tail end and get some free PSTN calling. But you always have to have at least one line for emergencies. The remote sites can use G.729 compressed codec, and this is currently Cisco's preferred compressed codec, and this series does not get into the newest flavor of the bunch, and that is ILBC, the Internet Low Bitrate Codec, which is suspected to become the new universal standard for compressed codecs. Gives you extremely high quality, gets about 15 kilobits per second of bandwidth or so. It has different flavors that can do both, but gives you the same level of quality as G.711 on the mean opinion score, which is a rating scale. It gets a 4.1 out of 5, which is the same rating that G.711 does. So this is going to be a great compressed WAN codec in the future, and again, maybe by the time you're hearing this is more popular, but for a long time in coming, G.729 will be the compressed codec of choice. That is 8 kilobits per second, even less. Gives you about 3.9 mean opinion score rating, so it's good quality, very high quality, very low amount of bandwidth. Great for WAN bandwidth savings that you can use when you're calling between the sites. One of the key features that you're going to need on this router is SRST. Survivable Remote Site Telephony. This allows this router to support the IP phones should the WAN connection fail, or even should all of the call managers, it's a rare occasion, but all the call managers in that cluster go down. You could even run SRST on this router and allow that router to run the phones even at the central site. It may not be all of them, but you can get a few key phones running so that they can dial to the PSTN and still have some phone functionality. SRST has become so good that a lot of people don't even know when their phones have flipped over to SRST mode. I mean, the phone works, it does hold, it gets music on hold, transfer, conference, everything works, just like a normal phone. It's just, the WAN is down and the router is now supporting that. So SRST is one of the key features you need to have if your WAN link fails, because it does. We lose VPN connections, we lose WAN links for your phone to keep operating. Eventually, your remote sites may outgrow that centralized call processing model. Once you start moving into the 50, 100 phones at the remote sites, it's like, okay, that remote site's now a pretty viable location. If it loses service, we're going to lose a lot of money, or you need some more support behind that than just a SRST gateway. That's where you move into a distributed call processing model. And this is where you have call manager clusters at each location. Now, remember, this is a single company, so you have this cluster over here that has its own database of phones that it's running, and it's maintaining solely this location and all of these phones over here. You've got a call manager cluster with its own database for this one, and so for any of these different clusters to communicate, you have to start creating a cluster dial plan to where you set up inter-cluster trunks between these locations. Or you can use an independent WAN device, such as we're going to talk about in this series, an H323 gatekeeper, where one of these routers can be a gatekeeper which everybody points to for centralized control of the dial plan and centralized control of the bandwidth. We actually talked about this in the previous nugget. The role of that gatekeeper is to centralize everything. So you can rely on that in that kind of distributed cluster environment to minimize the amount of those trunk links you'll have to create. You can still use compressed codecs over the WAN, like G.729, to save bandwidth, and you can use the PSTN as a failover path, to where if the WAN goes down, the routers and call managers can detect that and dynamically fail over across the PSTN to where the users don't notice anything. They can still dial each other by 4-digit extension, and the call managers behind the scene can transform the number. We actually go through a whole configuration for this in that CIPT series I was talking about, where it can transform the number on the fly to become PSTN compatible and change that 4-digit number into a number that will ring a phone over here, going across the PSTN rather than using an IP WAN. Pretty powerful stuff. Now, I jotted on here, I think this model represents the future of networks. Because I said this is one company this model is designed for, or, a couple partner companies or something like that. But I see this. Check it out. This is the future right here. Eventually, in my opinion, the PSTN as we know it and as it stands is gone. The PSTN becomes the single connection, which will now be the internet. Or, they're probably going to call it the Internet 2 by then, the second revision, IPv6 everywhere, and for what I'm talking about right now, we're talking flying cars, we're talking, Jetsons, Back to the Future 2 kind of things, floating skateboards, all that kind of stuff. I'm talking the future here. And who knows how long this will be, but eventually all calls will be traversing this Internet 2, and these people won't even be related. This could be, Nabisco over here, and this could be Intel over here on the left hand. Two totally unrelated companies. All their calls are traversing the internet. It's all being encrypted. Everything's secure. This is the future of networks. This is where everything is going to voice over IP. People have got instant messengers that can work as phones, that can tie to cell phones, that tie to TV screens. Everything is going to be just one unified communication medium, and that's Cisco's vision. That's where everything's moving to. The final type of deployment model is rarely used, but it is clustering over a WAN. What this model is all about is taking a call manager cluster where you have multiple servers that are sharing the same database, and you have, for instance, a publisher and a subscriber, and they're replicating all of their database over that single WAN link between those two. Now, the benefit of clustering over a wide area network connection is that you have a centralized administration. One database to administer, one database to manage. All of these phones can, be updated without doing any kind of intercluster trunks. No gatekeepers are necessary. All of this is managed and maintained centrally, one database. The problem of clustering over the WAN is it has some intense requirements. And the biggest, most intensest requirement of all, is the round-trip delay between these sites has to be 40 milliseconds or less. Meaning, I have to be able to get from this server to this server, over here, and back in 40 milliseconds or less. Now, to put that in perspective, the requirements for high-quality voice is 150 milliseconds one-way delay, meaning I just have to get from here to here in 150 milliseconds or less for high-quality audio. And some people are like, wow, that's going to be tough, delay, processing, all that kind of stuff. So when you look at 40 milliseconds round trip, meaning 20 milliseconds one way, people are like, no way. It's feasibly not impossible. In a lot of cases, it's not. For instance, if you have an office in California and then you have an office in New York City, just moving from coast to coast of the United States, it's not possible in 20 milliseconds or less. Just the sheer travel time. Or going from Arizona to India or some international region. It's just not possible. Geographically speaking, I can't move light from one site to another in that amount of speed, especially with all the routers in between and processing delays and all that kind of stuff. So this kind of model is really reserved for, I would say, locally connected organizations. Meaning you could have a site here in, we'll say, San Jose, California, and maybe a site right here in San Francisco, California. You've got fiber lines between those. Or, for instance, Phoenix, Arizona has a fiber run up to Utah, Salt Lake City. Utah, we've got a direct fiber line. So you've got fiber, you've got switching, no routing going between them. That would be a feasible solution to where you split your cluster over the WAN. But cases other than that, it's just not possible. So there are the building blocks of the voice network. Between this nugget and the last, we have now kind of laid the foundations, looked at the Lego pieces that we can use to build our voice over IP networks. If you've taken some of the CCVP series, other CBT Nugget series, some of those may have been familiar to you. You might have seen, for instance, the design models or the control agents or some of the stuff we talked about in the previous Nugget, like the gateways and gatekeepers and all those different pieces. But that brings us all to a common foundation that we can build on as we move forward and dive into our discussion of gateways and gatekeepers. So, to hit the high points, we looked at the call control agents, boiling it down to two primary ones, the Cisco Call Manager and the Cisco Call Manager Express, or Unified Communication Manager. The Cisco SIP proxy server and enterprise gateway have gone the way of end of life, and everything Cisco-wise has moved into this Call Manager model, which is excellent, in my opinion, because it's a whole lot less products to learn. We also saw the call control models, ranging from the single site to the centralized call processing to the distributed call processing models, where you've got your call manager clusters in each location, till finally breaking a clustering over a high-speed wide area network. All the different models that you can use to deploy voice over IP. I hope this has been informative for you, and I'd like to thank you for viewing.